Good afternoon, everyone. It is 5:30 already, so we will start. Today we will talk about wireline. I don't have so much participants so far. I think I have 15 online, but you guys, you are online now. Do you know what I mean by wireline? Are you aware of this service or not? I need to see your feedback. Do you know what's wireline? When I say wireline, do you know what this means? Let me have your feedback. Oh, no feedback. Is a well intervention technique. I hope you know what's wireline. Have you? It's one of the well intervention service. Yes, you're right. I start getting some feedback from you. Thanks. Yes, it is one of the well intervention services. The well intervention services mainly is wireline, coil tubing, and snubbing. These are the three main services in the, as we said before, well intervention means the technique of working on live well. It's a service we do on a live well. And during this hour, we will talk about the wireline general. If we need to talk about wireline, we need several lectures there. But we will talk about the wireline in 1 hour now. The wireline, it's a well intervention technique of conveying tools and instruments downhole. You need to run this device downhole. So you can use either, you can do that with wireline, you can do that with coil tubing, you can do that with the snubbing also. It is the most efficient and practical method of diagnosing well problems. For example, if we are running in the hole and we're supposed to go to 9,000 feet, but while running in the hole at 6,250, we couldn't pass. Why we couldn't pass? Oh, several answers. But the wireline is one service that can tells you quickly what's going on. Where we run with what we call gauge cutter. It's a small device. It will, when stops at this depth, will tell you that if you have what kind of restrictions, then you can run what we call impression block, which will give you a print of the profile that you stuck at or you couldn't pass at. So it's very simple, very easy. We have three categories of wireline. We have what we call slick line, solid line, piano line. This is what you see in front of you now. This is solid line. See, it's a solid, it's not hollow. It's a solid line, piano line. You call it piano line because it is very tiny, like piano lines. And we have braided line. This is a braided line. What you see now is braided line. In the third categories of wireline, we have the E-line. E-line stands for electric line. What you see now in front of you is electric E-line. See what's in the middle? It is electric cord, electric cable. These are the three categories of wireline. This is a slick line. This is a braided line. And this third line is the E line. It's like a braided line, but it has in the middle an electric cord. It's a multi-strand wire. Slick line, which is this one. We use it in the normal operation. The common size we use it is the 108. 108 stands for, this is the diameter of the wire, 108 of an inch. Normally, if the line is stuck and we break it, normally we need to fish it. Normally we fish it with a thicker wire line, 125 or 140. This is the normal practice in some areas of the world. But in this course, please note that fishing means braided line. When we need to fish, we need to use this one, braided line. That's why we made it for. We made it for fishing mainly. Because in fishing, you need more torque, more force, more tensile strength that a wire can withstand. So we don't gamble by using a thicker wire, slick line, but we go directly for braided line. So normal application of the slick line is the normal application like running tools downhole, setting tools, or removing a plug, or removing downhole city valve. This is the normal application of the slick line we use. But the braided line, which is a multi-strand wire, normally it is the size, the OD of it is 7/32 or 6/32. This is the one, 3/16 or 7/32. Sorry, this is the one. This is the braided line. And as I said, we use it mainly for fishing. We use it for swabbing also. So why we use it for these services? Because we need more tensile strength on the wire. The third line is the E line, electric line. The electric line is a multi-strand wire, but as we said, it has an electric cord in the middle. This electric cord allows us to have what we call SRO services. SRO stands for service readout. Service readout. So we can read pressure and temperature on surface while we are in. You are deep in the hole, but you still can get these measurements through this electric line, through a screen. You have it at the services. We use it in perforation and power car settings. This is the E-line application. Any wireline equipment consists of service equipment, PCE, which stands for pressure control equipment, and downhole tools, which is subsurface equipment. In this course, we will concentrate on number 2, which is pressure control equipment. Pressure control equipment, which is like a BOB, a lubricator, a riser, stuffing box, grease injection head. This is the item that we need to talk about a little bit. Subsurface equipment, we will not talk about it. It's not part of this course. What you see in front of you now is the rig up for a slick line. See the marks in green? Where is our primary barrier? It is the stuffing box on top. This is our primary barrier because while running in the hole, this is the wire, this is the slick line. What makes the seal, what prevents the well pressure escaping out, it is the stuffing box, because the stuffing box has inside these seals. See? These are the seals, rubber seals. These rubber seals seal around the wire, preventing the well pressure escaping to the surface. If you notice, these are four types of packing, right? Rubber element. If you notice, they are different in shape and in color. Do you know why? Can you tell me why these packings are different in colors and shapes, maybe material as well? Or it's just a manufacturer? Any idea? Let me have your answers. I have a question. What's the diameter of that braided line? Braided line is 3/16 of an inch normally, or 7/32 of an inch. Now my new question is, why these packing are different in maybe material and shape and size and color? No answer yet. No answer. Or differentiate, maybe they fit the different type of wire line. Let me, because they don't have same function. Yes, it is not the same function, but your answer is not definite. It's not a precise answer. When you go to do a job, so you ask me, Ahmed, please prepare your slick line unit because you have a job tomorrow on that location, on that particular well. You have to tell me, of course, I have to get many data. One of these data I have to get to prepare my unit is, this well is gas or oil? Sour service, I mean, it has H2S and CO2, or sweet service. High pressure, low pressure. High temperature, low temperature. Because based on that, I will select my packing that suits this. It's not the way that when you purchase packing, that you select the cheapest one. This will save you money, right? Actually, this will cost you money. Because if you are working on H2S well, and you use packing, which is standard service, what will happen during the job? The H2S will eat your rubber and you might have a blowout. So my selection on the packing depends on the answers I got for my questions. High pressure, low pressure, high temperature, low temperature, gas or oil, sweet or service. Based on that, I select the right packing for this particular job. So the stuffing box, which is on top, primary barrier. Where is my secondary barrier? If my primary barrier failed, which is the stuffing box, my secondary barrier is the BOB, the blowout preventer. Where is my tertiary barrier? If my secondary barrier, which is the BOB failed means you closed, again is the slick line, but this BOB doesn't prevent the flow of hydrocarbon. My tertiary barrier is the Christmas tree, this one. Which part of the Christmas tree? It is the upper master valve. Why the upper master valve? Because it has, look what I wrote here, it has the wire cutter capability. So, if in another drawing, this is the swab valve, right? So I said, this is a swab valve, and then between brackets, I wrote wire line capability. Then your tertiary barrier is this swab valve. You are looking for the tertiary barrier that cuts, as we say always, that primary barrier and second barrier, mainly they are sealing barrier, while the tertiary barrier is a shear. It has the cutting capability. Normally, we put the cutting capability, as we agreed before, on the upper master valve because it is not manual, it is hydraulic or pneumatic, so it has more force to cut than your hand. What you see here, this is the wire, this is the slick line that starts from here. This is the winch. This is the drum that has the slick line. It goes out, passing by this, which is the weight indicators. It goes up to the stuffing box and then enter the weight. This weight indicator that weights the weight of the tools and slick line you have in the well. This angle, you see it here, has to be 90 degrees. Let's have a closer look at this angle here. This is your weight indicator. This is the angle that it has to be 90 degrees. Why it has to be 90 degrees? So the measurements, the reading you have on the weight indicator will give you the exact weight you have in the well. The relation between the angle and the weight is, if the angle is 90, you are getting the exact weight. If the angle is more than 90, your weight will be less than actual. And if the angle is less than 90, then the reading of weight you got is more than actual. And of course, in some location, in some rig-ups, the geometry of the well and of the condition that will not allow you to have 90 degree sharp. Yes, that's why we have a correction factor. We have a table. If your angle is 120, then you multiply by this factor. If your angle is 80, you multiply by this factor to get the correct reading of the weight. These are some types, some pictures of slick line unit. When you rig up slick line, if we go back to the last session, which we were talking about completion. This was our Christmas tree. And if you are rigging a slick line, we said you go up, you take this cap out, then you have a thread here. Then you start putting your crossover that will match between the thread of the cap of the Christmas tree and the thread of your equipment. So first thing is the crossover. The crossover is mainly the thread that we use on the crossover is what we call Acme thread. 5 3/4-4 Acme thread. Why it has two numbers? Normally, when I call this thread, if you see this thread, this is MPT thread. This is quarter inch. MPT thread, national pipe thread. But why this one has two figures, two numbers, 5 3/4-4? Because this tells you that this is the size, 5 3/4, this is the diameter. -4 means it has 4 threads per inch. 4 threads per inch. But this type of thread, which is an Acme thread, the thread itself does not make the seal. What makes the seal is this black spot here. You see, this is the O-ring. This is the O-ring, which is this one. This is what makes the seal. That's why this type of thread, which is the Acme thread, it is hand tight, no wrench. You don't have, because what makes the seal is this one. It's different than the MPT. This is the MPT thread. When you connect it, male and female, use your hand, but then you have to use a spanner to tighten it, because what makes the seal is the thread itself. But this is not the case with the Acme. What makes the seal is the O-ring, and that's why we have to take care of this O-ring. And we say it is one-time use. One-time use. Once you finish the job, please take this out, kiss it goodbye. And once you kiss it, and before you say goodbye, please cut it, so no one else can use it. Even if you do so, some other people will come and use it. They bring that one from the garbage. It is a split already, right? And he will bring a Teflon tape, and he will start roll this Teflon tape around the diameter, and then he will reuse it. One-time use. Look at this one in front of me, in front of you. Look at that. It's really nice. It's black color, smooth surface, no tears, no cuts. It is flexible. I can guarantee you, if you reuse it, if you use it now, it will leak. Why I'm sure of that? Because the life of this O-ring expired long time ago. Even this one, what's inside is an O-ring, brand new, never been used. If you take it out of the box, and if you use it, it will leak. Because this rubber, even if it is not used, it has a shelf life. 3 years, for example, shelf life. So If you put it on the store for 3 years, air-conditioned store for 3 years, and you didn't use it, please open your store, take it, kiss it, throw it. No use. Explosive decomposition or explosive decomposition, it's a phenomenon that happens to all your rubber elements, which is exposed to gases. Rubber although you think it is solid, but it absorbs gases. It absorbs gases up till saturation. So this rubber element now, which is your barrier actually, regardless this or the BOB, RAM, whatever, these gases which became inside the rubber element, when it is heated, when the condition, the temperature rises, these gases start to expand. Where to expand? It is confined space. So it will cause tearing, blistering to the rubber element. It will damage your rubber. So if this phenomena happens, what should you do with this rubber? Throw it. Not just this one. If you have a BOB and you are doing a regular maintenance, so you split it, you take it apart, and let us assume that you have 12 rubber elements on this BOB, blow-up preventer. And you notice that this phenomena, which is explosive decomposition, happened already in 2 rubber items, but the other 10 is okay. Do you change only the 2 rubber elements? No, you change all, because they are all exposed to the same condition, to the same environment. So if you change only 2 and you put it back into work, after half an hour, another one will have this phenomena. Another one. So please change them all. They are all damaged already. We said our primary barrier is the stuffing box. What you see in front of you now is a stuffing box. 2 different stuffing boxes. One here I said hydraulic stuffing box, and this one is manual stuffing box. Let us see the questions, because well, right, excuse me, I didn't understand. Excuse me, I didn't understand. Where do we use the quick union in the wireline equipment rig? Yes. I said, answer your questions. When you rig up your wireline equipment on a Christmas tree, so you go to the Christmas tree. This is the Christmas tree. You need to rig up now your wireline. What do you have here on top of the Christmas tree is the tree cap. To be able to rig up your equipment, so you have to connect your tools, your equipment to the Christmas tree. So you have to remove this cap, this tree cap. Then what you will have on top is a thread. Then you have to connect your BOB, because your BOB is the first thing you normally put on top of the Christmas tree. But normally, the BOB thread type and size maybe will not match the tree cap size. So you have to have a crossover, what we call quick union. Why it's quick union? Because it is hand tight. So you have to have this crossover to have the connection between the Christmas tree thread and size and your equipment thread and size. That's why you have the quick union. First thing you put on top of the Christmas tree. Back to this manual stuffing box, hydraulic stuffing. The manual stuffing box should be at the museum. We stopped using this long time ago. What we are using now is the hydraulic stuffing box. Anyhow, we'll see the difference now, but this is our primary barrier. If you notice, this is the packing, which seals around the wire. These are the packing. Here it is. This is the packing that seals around the wire. While in and out, there is a friction between the wire and the rubber. Who wins? Of course, the wire. Start eating the packing. So the packing is not sealed. It's not sealed around the wire, so it starts leaking. Hydrocarbons start coming out. So what we do, in the manual stuffing box, you have to hire a monkey. So the monkey will jump on the rig up top with the pipe wrench. So he used this gland nut to squeeze it. So when you squeeze the gland nut will squeeze the rubber packing. The packing will squeeze on the wire to make the seal. While in the hydraulic stuffing box, you don't have to hire a monkey. You hire a human being. So when it leaks, all what you have to do is to have a connection here with this. All the way you have a hydraulic hose connected to a hydraulic pump, hand pump, high pressure hand pump. When you apply this pressure, it goes through the hydraulic hose. Here you have piston and cylinder. So the piston move downward, squeezing the packing on the rubber, on the wire to make the seal. This is how the seal works. Here we have a safety device. We call it plunger. If we don't have the plunger, let us assume that we run in the hole. We did our job and we start pulling out of the hole. And while pulling out of the hole, you are not concentrating on the job. Your mind was in something else. And you are pulling out of the hole now without, you lost your tools. The wire is cut, you lost the tools. Now you are getting out of the hole with the wire line free. That means that when you reach the surface, nothing will stop you from getting out of the stuff. What comes out after that? It's a blowout, hydrocarbons. To prevent this from happening, we put this black device, which we call plunger. This is the plunger. See this hole, the middle? And this is how it is. Now you are pulling out of the hole. The moment the wire is out of the plunger, hydrocarbons are coming out. So it will push this plunger up, squeeze it in this profile to act as a blind, preventing the hydrocarbon escaping out of the well. Yes, I know that it has a hole in the middle. But you see this upper part? The upper part is rubber, while the rest is metal. This upper part is rubber, so it will be squeezed to go inside this profile and act as a blind. And that's why this plunger, or this plunger, we call it stuffing box BOB. We call it plunger. We call it blowout plug. All the same meaning, all the same for the same part. The stuffing box is nice as long as you work on slick line. You need to seal on polish board or seal board on a solid line, smooth surface. But if you have braided line, if you try to seal around it with rubber and put the maximum pressure you can apply, pressure will escape from this braided line. It's braided. So this technique will not work. And that's why when we work with braided line or with E-line, we don't use stuffing box. We use grease injection. This is the grease injection head. What makes the seal is this blue part here. If we take it out to see what's there, you will see it's a pipe. You see a pipe, we call it flow tube. Now, what's inside the flow tube is our braided line, E-line. Now we need to make the seal between the OD of the braided line and the ID of the flow tube. How we make this seal? We fill it with grease. Fill this volume with grease. How we use that? With this system. We have a pump. This pump injects grease. Grease goes to the grease inlet at the bottom of the grease injection head, and it goes out from the top of the grease injection head back to the pump. So it is a closed cycle, continuous, clockwise direction. Always the pressure is pumped through the lower inlet here. Grease is coming out from top back to the pump. And we keep this circuit pressure at least 1.2 in maximum wellhead pressure. So if the wellhead pressure is 1,000, we keep this circuit as 1,200. So pressure, well pressure will not escape out. But of course, you have to tell me now, yes, Ahmed, you're right. I have another problem that now this circuit is 1,200 and the well pressure is 1,000. So the grease, which is in the higher pressure circuit, will go down the well. What prevents this grease from going into the well? And what prevents it from coming out of the stuffing box or out of the grease injection head? What does this is, if you look at the top of the grease injection head, we'll see this system, which is mainly piston and cylinder. And then we have here what we call element wiper. This element wiper, which is the rubber element, the function of the element wiper is, while pulling out of the hole, this is the braided line. So it is full of grease. So we need to clean it. So the element wiper is in contact with the E-line or braided line. So while pulling out of the hole, it cleans from grease. This grease that you remove from the wire, it goes through this drain hose. It goes to a separate container, then you throw it. It's contaminated already, you cannot use it again. By time, there is a friction between an element wiper and the wire. Who wins? Game, it is the wire. So the element wiper is not in contact with the wire, so it does not clean. That's why we have this system piston cylinder, where we have here hydraulic hose goes all the way to the hand pump. Then with this hand pump, you apply pressure. Then this piston will go down, pushing the element wiper down to get in contact again with the wire to clean it again. This kind of pressure you apply, it prevents the escape of this grease out. And if you look at the clearance between this OD of the wire and the ID of the flow tube, I write it here, it's almost 0.005 of an inch. So the volume that you fill this part, it's very, very small. So even if you have a leak, it is very, very, very small. And it is true that when you start the job and this drum is full of grease, you end up the job and this drum might have half of it, 3/4, 2/3, 1/4. It depends on a lot of things, the duration of the job, and also it depends on the experience of the operator. Because one operator, he knows that the wellhead pressure is 1,000, so he will keep his circuit as 1,200. But another one, he will keep his circuit as 1,500. The one who keeps his circuit as 1,500, he might think he is more safe. Actually, he might be in danger because he will lose more grease. He might lose all his grease before the end of the job because he makes the differential pressure is too high. So more grease will go down. To eliminate the volume of grease going down also, in this regard, let's have another view of the flow tube. Here we have, this is the flow tube. This is the grease injection head. You will notice that here we have 1, 2, 3 flow tubes. And one of them, which is the lowest one here, it is below the grease inlet. The grease inlet, which is at bottom. How many flow tubes we use in the well? I don't know. I have to get some information from you to be able to answer this question. But normally, we have a table with categories. When you increase the pressure, you increase the number of flow tubes. And also, with the same pressure rating, with the same pressure category, if it is oil or gas. Normally, in gas, we add more flow tube than oil. But the lowest flow tube here, the one we put below the grease inlet, it has another function actually. It has a clearance less than 0.005 of an inch to minimize the loss of grease into the well. The volume is less, so it minimizes the loss of grease. You see here, for example, if you are using a well category from 5,000 to 7,500 psi. If it is liquid, we'll use 4 flow tubes. With the same pressure, if it is gas, it is 5 flow tubes, so 1 more flow tube. In the stuffing box, when you were pulling out of the hole and you didn't notice that you lost your tools. So we have a safety device in the stuffing box itself, which is the plunger. But in the grease injection head, we don't have this safety device. That's why below the grease injection head, we put here a device, we call it SCU, Safety Check Union. This device, Safety Check Union, we put it in the rig up below the grease injection head. This is how it looks like. This is the Safety Check Union. When the wire is inside, the ball, this yellow ball, stainless steel ball, it is on the side. But the moment the wire is above this ball, the ball will be dropped to the middle. What comes after? It is the well pressure. So the well pressure will push it up to let it sit in the seat here, act as a blind, preventing well pressure escaping to the surface. This is the function of the ball check valve, safety check unit. At the top of the rig up, we have stuffing box. Then normally we have two-section lubricator. Why we do have lubricator in any rig up? This is a question I need you to answer. Why we have these, we use these lubricators in our rig ups, whatever it is, slick line, wire line, or E-line, or coil tubing. Why we use the lubricator? I need to have your answers, please, with me. I'm eager to see your answer. Why we use lubricator in the rig up? Even if you don't know, think. Try. I will not kill you for a wrong answer. To convey the downhole tools connected to the wire line and get it ready. You have another answer. Support the system for the weight. I don't have a good answer so far. I have 42 participants live with 2 answers only. 2 people answered and 40 didn't answer. They don't have an answer or what? I don't know. I'm waiting more answers. No answers. The main reason for a lubricator is, you see, I got one answer. BHA length. Yes. I'm happy I got a good answer. BHA length. Yes. The main reason for a lubricator in the rigger is to accommodate the bottom hole assembly length. To be able to rig up on surface while the Christmas tree is closed, to make a complete rig up and pressure test your system before you open the swap valve, run in the hole. This lubricator is to accommodate the total length of your BHA, bottom hole assembly. What is your bottom hole assembly? It is the tools that you are running. Yani, from top, first thing you have, from the slick line, you have what we call rope socket, which is the connection from the wire line or the E-line, is the slick line that gives you at the end thread. So you can connect your tools. Your tools could be stem bars, centralizers, knuckle joints. You can have running tools, shifting tools, kick-over tools, jar, spears, whatever. So these are bottom hole tools. The lubricator is mainly to accommodate the length, the total length of the BHA. And normally, the lubricator should have a length bigger than the tools. I mean, if you have a 9 feet length, normally this lubricator comes in 2 versions, 4 feet and 8 feet. So if you have a total length of your BHA is 9 foot, then you have to use two lubricators, one 8 feet and one 4 feet. So we have total 12 feet length. So this is the main reason why we use lubricator. This lubricator you see in front of you is an obsolete. This one banned from years ago because it is not integral. What do I mean by integral? One piece. It has to be one piece. What you see in front of you is not one piece. If you have a cross-sectional area, this is what you see here. This connection, this piece is connected to that piece. This piece is connected to that piece. This piece is connected to that piece. And if you see what we have internally, we have an O-ring to make the seal for every connections we make. This is rubbish because nowadays it have to be integral, which means one piece. One piece means that it is not connected in several pieces because every connection you make is a possibility of leak. So you have to minimize your connection, to minimize your possibilities of leaks, to increase the safety in the rigger. Some people believe that this too has to be one piece. No, each one has to be one piece. But in the rigger, you can have 2 or 3 or 5 or 6, depends on the total length of the tools. But every one of them has to be one piece. Here, this one, I call it lower lubricator, lower section. And this one is the upper section. Can I use this one as the lower section and this one as an upper section? Of course not. If I use this, the upper section, then every time I need to read pressure or need to bleed off, I have to use helicopter to go up. I have to use scaffolds. This one has to be the lower end. This has to be the upper section. For years in the field, the word lubricator and the word riser mean the same for me. They are the same, lubricator or riser. Till I got some knowledge. This knowledge say that what you see in front of you is not a riser. It is definitely a lubricator. Why? In the life lectures, when I deal with a human being in front of me, yani not like you guys, you are on a screen. I received some answers, some funny answers. I said, why this is a lubricator? Because it is not a riser. Then I got an answer, because of the size, Mr. Ahmed, or because of the length. Then I look back to my screen. How do you know? There is no mention of diameter or distance or length here. But actually, the difference between the lubricator and riser, the lubricator is thread connection. The riser is flange connection. Again, the lubricator is thread connection. The riser is flange connection. And that's why in the cold tubing, when we rig up, all our rig up has to be flange to flange. Still on the slick line, we use thread to thread. But the thread is not designed to withstand torque, while a flange is. So if you rig up, if you finish the rig up, and your rig up is 90 degree like that, you have no problem. But you're not 90 degree. In reality, it shakes during run hole and pull out of the hole. All what you need for a disaster to happen, to have 1 degree of 90. So if you are 1 degree of 90, the force applied to the connection below here is the weight times the distance. If we're talking about coiled tubing, the weight of the injector is 6 tons times 30. This force that applies to the thread cannot withstand it, but the flange can withstand that. So the difference between the riser and the lubricator, actually it's a thread. Riser is flange connection, thread is the lubricator is thread connection. I believe this is the last device we'll talk about before we end this session. This is what we call pressure test stub. If we don't have this device in the rig up, we rig up a slick line, we did a pressure test, then we start running the hole, we reach the depth, we did our job. So now we need to pull out of the hole, change the tools, and run again. If you don't have this device, you pull out of the hole, close your Christmas tree, bleed off your pressure, rig off. Change your tool, put the new tool, rig up. Before you run in the hole, you have to make another pressure test for the whole equipment. But having this device, which normally we put it on top of the BOD, so when you pull out of the hole, close your swap valve, bleed off your pressure, you disconnect from this device, which is on top of the BOD. Disconnect, rig off, change your tool, put the new tool, rig up again. Now, you don't have to make a complete pressure test for your equipment, but you pressure test only the device you just disconnect. How? You connect here hand pump, high pressure hand pump. This high pressure hand pump here, it applies pressure. This pressure goes between these two O-rings, one here, one here. So you are pressure testing only the connection you just disconnect. You don't pressure test the whole rig up. So this quick test sub, it saves actually time and volume for retesting. You only test this device. This is what we call pressure test sub. It is 6:30 already local time here, but let me have, okay, no. So unfortunately we reached the end. I'll stop here. So Sunday will continue, and we still have one complete session on slick on wireline. Next session will be number 8. We can finish that, or we can talk about coiled tubing a little bit. But if we talk about coiled tubing, we need another 2 sessions. So, but I have no problem with that. So, Dr. Ahmed, I'm done for today, and I'll see you Sunday, guys. Let me see if you have any more questions here. Inshallah, yes, Fatima. Okay, Dr. Ahmed, I'm ready to leave.
Ahmed, thank you very much for the session of today. And for sure, we'll be happy to see you again on Wednesday and Sunday.
Sunday, inshallah, 3 o'clock.
Inshallah. See you.